The final little bit of teaching in the Radians chapter that we're going to cover is the area of segment. Now, this is, I think, one of the neatest things about using Radians in terms of physical properties of circles, areas, and perimeters and such, because it takes quite a difficult, awkward thing to work out, and it tidies it up really, really nicely. So, if we just start with our circle, that's not a circle. Let me try that again. That's a bit more circle-like. If we start with a circle and we just draw in a sector, so we've got a radius of r and an angle of theta. If I then cut it here so that we are looking for the area of this segment just here, hopefully you're all happy that that is a segment. That is the definition of a segment. What we would have to do at GCSE, and some of you may have seen this at GCSE, although it's quite top end, so perhaps not all of you really did much work on this type of question, is the area of the segment it's the area of the sector minus the area of the triangle that you can see. So we just basically take away this triangle. So we have a nice big sector here, we subtract the triangle, and what we're left with is the segment. Now, that it is an awkward thing to do at GCSE because you have to find the area of the sector in the first place, which is top end maths anyway, and then on top of that you've got to find the area of a triangle where you don't know base and height, and so that's a bit of a fiddle, and then you have to combine those two things. Now, you know a bit more maths at this point. We did a whole load of work on trigonometry in year 12, and we talked about the formula for finding areas of triangles. So what we have is the area of this sector, well, the area of a sector is half r squared theta, like we just looked at, and the area of a triangle is, well, we know r, and we also know this r right here, and so we know the area of a triangle is actually half AB sine C, where C is the included angle, and you'll notice that A and B are both the radius, so they're actually the same. So what we end up with is half r squared sine C, C is theta. So this particular triangle has an area of half r squared sine theta. So this is the formula for the area of the segment. It's half r squared theta, take away half r squared sine theta. And what I love is those are incredibly similar looking things. In fact, they're so similar that we can factor out almost all of it. We can factor out the half r squared, and we end up with theta subtract sine theta. We end up with this marvelous formula where the area of this segment is just half r squared, and then theta take away sine theta. So we've got the angle in its normal form, and then a trig function of the angle in these brackets. Now, honestly, I wouldn't necessarily recommend trying to memorize that, because there are many ways to memorize that wrong. What I would strongly suggest is that you just try and memorize the fact that it's the area of the sector take away the area of the triangle, because actually trying to deal with these sorts of triangles is often useful in circle questions. So spotting straight away that this is half r squared sine theta is quite a useful thing to be able to notice. I would be memorizing this version here, the top one, half r squared theta, take away half r squared sine theta. But it is really lovely and beautiful that it tidies up so neatly. And the page in the textbook, it just walks through these steps for you, and it gives this formula as the one to memorize and to use. If you are good at memorizing formula and you want to hang on to that and use that directly, then that's absolutely fine. You're obviously not going to lose any marks for it. Generally speaking, I would recommend remembering where a thing comes from to the extent that you can reproduce it quite quickly and easily. This is not a hard thing to figure out from scratch, but it probably is a hard thing to memorize perfectly.